How do we obtain the required partial differential equations when there are two arbitrary functions? So if there are two arbitrary functions, then we have to go up to the second order partial derivatives. So let's take a few examples and we shall see how we can obtain the partial differential equation. Let's consider the first example. So z equals x, f1 of x plus t plus f2 of x plus t. So call this as equation 1. So we have two arbitrary functions f1 and f2. So now we have to partially differentiate z with respect to x and with respect to t. So partially differentiate with respect to x and with respect to t. So del z by del x equals the first function x into f1 dash x plus t plus f1 of x plus t plus f2 dash x plus t. Now partially differentiate z with respect to t. So del z by del t equals x into f1 dash x plus t plus f2 dash x plus t. Now we have to differentiate both of them again with respect to x and t. So now we have del square z by del x square equals, so I'm partially differentiating this with respect to x again. So you have x into partially differentiate this, so you get f1 double dash x plus t plus f1 dash x plus t into differential of x partially is 1 plus partially differentiate this f1 dash x plus t plus f2 double dash x plus t. So call this as equation 2. So now let's partially differentiate this with respect to t. So you get del square z divided by del t. So I've already differentiated z with respect to t. Now I'm partially differentiating this with respect to x. So you have x into f1 double dash x plus t plus f1 dash x plus t into 1 plus f2 double dash x plus t. So call this as 3. Now partially differentiate del z by del t with respect to t. So you have del square z by del t square equals x into f1 double dash x plus t plus f2 double dash x plus t. So call this as equation 4. So observe that in equation 2 and 3 we have x f1 double dash plus f2 double dash. So this entire term is equal to del square z by del t square. So we observe that this is already present here. So you have x f1 double dash x plus t and here you have f2 double dash x plus t. So these two terms, the first term plus the fourth term, is nothing but del square z by del t square. So I can rewrite del square z by del x square as del square z by del t square plus, so these two can be added, 2f1 dash x plus t. So call this as equation 5. So similarly this term is present here also. So you have x f1 double dash x plus t and f2 double dash x plus t. So what happens? So let me write it here. Del square z by del x del t equals, so the first term plus the third term is equal to del square z by del t square plus f1 dash x plus t. So call this as equation 6. So now let's observe equation 5 and equation 6. Now we have to eliminate 2 times f1 dash x plus t. So here I have 2 times f1 dash x plus t, here I have f1 dash x plus t. So multiply equation 6 with 2 and perform equation 5 minus equation 6. So let's see what has to be done. So perform equation 5 minus 2 into equation 6. right? So this is equation 5, del square z by del x square minus twice 2 into del square z by del x del t equals equation 5, which is del square z by del t square plus 2 f1 dash x plus t minus twice equation 6, which is minus del square z by del t square minus 2 times, so I need to multiply this by 2, f1 dash x plus t. So whole idea was to eliminate this, so these two terms, they get cancelled. Del square z by del t square minus 2 del square z by del t square is minus del square z by del t square. So LHS remains the same. So bring this to LHS, you would get del square z by del x square minus 2 del square z divided by del x del t plus del square z by del t square equals 0. So this happens to be the required partial differential equation. So you've observed that if a given expression has two arbitrary functions, we have to go up to the second order partial derivatives to get the partial differential equation, as we have done in this example. So let's take another example. Z equals f1 y minus 2x plus f2 2y minus x. So now let me partially differentiate z with respect to x. So del z by del x equals f1 dash y minus 2x, and I have to differentiate this with respect to x, so I get minus 2. And then you have f2 dash 2y minus x, and if I partially differentiate this with respect to x, I get minus 1. So this into minus 1 is with a minus sign here. Partially differentiate z with respect to y, so del z by del y equals f1 dash y minus 2x into 1 plus f2 dash 2y minus x. Partially differentiate this with respect to y, I get into 2. Now partially differentiate del z by del x with respect to x again. So you get del square z by del x square equals, so you have f1 double dash y minus 2x. So I already have minus 2 into minus 2 will give me 4. So minus 2 into minus 2 gives us plus 4. And then you have f2 double dash 2y minus x into minus 1. There's already one minus sign here. Minus into minus becomes plus. Now differentiating this with respect to x, you get del square z by del y del x equals, partially differentiate this with respect to x, so you get f1 double dash y minus 2x into minus 2. Then you have 2 f2 double dash 2y minus x into minus 1, so that's why I put minus sign here. Now partially differentiate del z by del y again with respect to y, so I get del square z by del y square equals f1 double dash y minus 2x into 1 plus f2 double dash 2y minus x. So you already have 2 into 2 gives us 4. So let's call this as equation 1, 2 and 3. So now we have to eliminate f2 double dash first. So observe that if I multiply equation 1 with 2 and add it with equation 2, this term gets cancelled. So multiply equation 1 with 2, 2 into equation 1 and add it with equation 2. So multiply this equation 1 with 2, so I get 2 del square z by del x square plus del square z by del x del y equals, so here I am multiplying this with 2, so 2 into 4 gives me 8. You get 8 f1 double dash y minus 2x, and then here you get 2 f2 double dash 2y minus x, and here you have minus 2 f2 double dash 2y minus x, so these two get cancelled, and here you have minus 2 f1 double dash y minus 2x. So this is what we get. So observe, this is 8 f1 double dash minus 2 f1 double dash. So we have 2 del square z by del x square plus del square z by del x del y equals 6 f1 double dash y minus 2x. So call this as equation 4. So again, consider equation 2 and 3. I have to eliminate f2 double dash here. So here you have minus 2 f2 double dash. Here you have 4 f2 double dash. So what can be done? Multiply equation 2 with 2 and add it with equation 3. So 2 into equation 2 plus 3 will eliminate the second term here in the RHS. So multiplying equation 2 with 2, you get 2 del square z divided by del x del y equals, I'm multiplying this equation with 2, so I get minus 4 f1 double dash y minus 2x, and of course these two terms, they get cancelled because this becomes minus 4 plus 4, and then plus f1 double dash y minus 2x. So again observe, this is minus 4, this is plus 1 of f1 double dash y minus 2x. So you have 2 del square z divided by del x del y plus, I also have this term which I forgot to write, plus del square z by del y square, right? So plus del square z by del y square equals minus 3 f1 double dash y minus 2x. So call this as equation 5. So observe, in equation 4 and 5 RHS you have f1 double dash y minus 2x. Here also you have f1 double dash y minus 2x. So now what do we do? These two expressions have to be eliminated. So perform 4 by 5. So divide equation 4 by 5. So 2 del square z by del x square plus del square z by del x del y divided by equation 5 is 2 del square z by del x del y plus del square z divided by del y square equals 6 f1 double dash y minus 2x divided by minus 3 f1 double dash y minus 2x. So these two terms gets cancelled. 3 2s are, so you get minus 2 here, right, with a minus sign. So this gets multiplied with minus 2. So 2 del square z by del x square plus del square z by del x del y. I'm multiplying this by minus 2 equals minus 2 into 2 is minus 4 del square z by del x del y minus 2 del square z by del y square. So bring this to LHS. So minus 4 becomes plus 4. So 4 plus 1 gives us 5, and this also comes to LHS. So we have 2 del square z by del x square plus 5 del square z by del x del y plus 2 del square z by del y square equals 0. So this happens to be the required partial differential equation. So observe that when you have to form a partial differential equation, when there are two arbitrary functions, we cannot obtain the partial differential equation by just partially differentiating z once. So we have to go in for the second order partial derivatives so that you get the partial differential equation. So this is how we have to perform and solve and get the partial differential equation, right? So do not forget to like, share and subscribe, and to view all the other videos related to partial differential equations, check out the links given in the description. And thanks for watching.